Hello. Now we will study section 2.6 accuracy, precision of instrument and error in measurement. These terms we need to define what is accuracy, precision and error. Measurement is foundation of all experimental science and technology. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty is called error. So the result of every measurement here from here you can write the definition from here to up to here. What is every calculated quantity which is based on measured value also has an error. We shall distinguish between two terms, accuracy and precision. The accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. Precision tells us to what resolution or limit the quantity is measured. The accuracy in the measurement may depend on several factors, including the limit or the resolution of the measuring instrument. For example, suppose a true value of certain length is near 3.678. This is our true value. Suppose this is the true value of one experiment. In one experiment using a measuring instrument of resolution 0.1 centimeter. Here the instrument that we are using, its resolution is 0. Up to 1 decimal places, is found to be 3.5 centimeter, while in another experiment using the measuring device of greater resolution, this is the second device whose resolution is slightly better, up to 2 decimal places. The length is determined to be 3.38 in this experiment. Here we have 3.38. The first measurement has more accuracy because it is closer to the true value. 3.5 is closer to the 3.678. But less precision. Its resolution is only 0.1 centimeter. While the second measurement is less accurate but more precise. Thus, every measurement is approximate due to errors in measurement. In general, the errors in measurement can be broadly classified as systematic error and random error. So here we see that using even the more resolution is in the second instrument, we have get the less accurate result. But there is more precise result because it is up to 2 decimal places. But here we get the only up to 1 decimal places, but it is close to 3.678. So it is more accurate. First case is more accurate, less precise. Second case is more precise, but less accurate. Systematic error. The systematic errors are those errors that tend to be in one direction, either positive or negative. Some of sources of systematic error are instrumental error that arise from the errors due to imperfect design or calibration of the measuring instrument. Zero error in the instrument. For example, the temperature graduation of the thermometer may be inadequately calibrated. It may read 104 degrees Celsius at the boiling point of water at STP, whereas it should be 100 degrees Celsius. In a vernier calipers, the zero mark of vernier scale may not coincide with the zero marks of main scale, or simply an ordinary meter scale may be worn off at one end. So here we see that instrumental error is due to improper calibration. Calibration means its 0 point is not properly set. And in vernier calipers, we first have to means coincide the zero mark of main scale with the not calibrated in vernier calipers, or simply an ordinary meter scale may be worn off at one end. Imperfection in experimental technique or procedure. To determine the temperature of human body, a thermometer placed under the armpit will always give a temperature lower than the actual value of the body temperature. Other external conditions such as changes in temperature, humidity, wind velocity, etc. during the experiment may systematically affect the measurement. Personal error that arise due to an individual bias, lack of proper setting of the apparatus or individual carelessness and taking observation without observing proper precaution etc. For example, if you by habit always hold your hands a bit too far to the right while reading the position of the needle on the scale, you will introduce an error due to parallax. Means if you are not handing anything in front of eye, you may find that the error due to parallax. Parallax means because scale is transparent, and you will seeing the each mark through some an angle. So you will introduce the personal error due to your bad habit. Systematic errors can be minimized by improving experimental techniques, selecting better instrument, and removing personal bias as far as possible. So this is the method to avoid how to avoid systematic error. You can mark here from here. For a given set of these errors may be estimated to a certain extent and the necessary correction may be applied to the reading. We can even apply it if we know the source of systematic error. We can apply after the results and correct it. Random errors. The random errors are those errors which occurs irregularly and hence are random with respect to sign and size. This can be arise due to random and unpredictable fluctuation in experimental condition. Example: unpredictable fluctuation in temperature, voltage supply, mechanical vibration of experimental setups, etc. Personal unbiased errors by the observer taking reading etc. For example, when the same person repeats the same observation, it is very likely that he may get different reading. So now we will read the list count error, and after that we will stop here. The list count error is the error associated with the resolution of the instrument. For example, a vernier caliper has a list count of 0.01 centimeter. A spherometer may have a list count of 0.001 centimeter. List count error belongs to the category of random errors, but within the limited size. It occurs with both systematic and random errors. If we use a meter scale for measurement of length, it may have graduation of 1 millimeter division scales spacing or interval. Using instruments of higher precision, improving experimental technique, etc., we can reduce the least count error. Repeating the observation several times and taking the arithmetic mean of all the observation, the mean value would be very close to the true value of the measured quantity. So here we see that how the list count error is introduced due to limitation of the equipment using which we are measuring the quantity. Right, that brings us to discussion on this instrument will give us more, can guarantee to give us more precise result, but this cannot guarantee us to give us more accurate result. Maybe this experiment, if you perform better using this experiment, we will get the more accurate result, but less precise, always less precise result. So the list count is error is due to the resolution of the equipment we are using to measure the quantity. Next lecture, we will try to introduce how to take the using mathematical methods and the experiment we have conducted, how to achieve to the true value, how to get the true value of the measured quantity. Thank you for this lecture, and we will stop.